This video, this one is for Retabili as well. This is 2019, I think it is anyway. 2019. This is the February-March paper. No, it's not. It's the October-November paper. And I think it's paper 42. I think it is anyway. So it's 2009, if you want to check the answer scheme. So an aqueous solution of copper sulfate is electrolyzed with copper electrodes. A current of that is passed, 1.5 amps, for 3 hours, and we get that much copper. We've got a charge on an electron is that. The relative atomic mass of copper is that, and using that, we've got to try and figure out Avogadro's constant. Now, these are quite common questions, actually, and this one was worth 5 marks. So even if you can't do it, let's imagine that you're stuck at some point. You can get loads of the marks by just by doing very straightforward stuff. Okay, so let's go. First of all, what's the charge passed? Q is equal to IT. I is 1.5 times T. T is 3 hours times 60 minutes times 60 seconds. Okay, and obviously I haven't got my calculator. So let's see if I can use this one. Right, gosh, it's an Apple calculator. So it's taking me forever to find it, obviously. Where is it? All right, there it is, calculator. All right, now clear it, and it's 1.5 times 3 times 60 times 60, and it's 16,200 coulombs, I think. I hope the calculator hasn't messed me around there. So 16,200 coulombs. That will get you a mark straight away, just doing that. Okay, now we want to find out the number of moles of copper. So the number of moles of copper forms. Number of moles of copper is equal to, what is it? It's 60, oops, no, it's not. It's 5.09 divided by 63.5. And what's that? That is 5.09 divided by 63.5. Again, I know I've said this before, but it's me waffling on and using a calculator and stuff. I would do these videos at double time, I must admit. So that's 802 moles of copper. Okay. Now, if you remember, copper 2 plus 2 electrons gives copper. So that must mean that the number of moles of copper passed, or copper formed, or copper deposited, is 0.0802. So the number of moles of electrons that passed is 2 times that. Again, that will give you another mole. So we times that by 2. And the number of moles, therefore, number of moles of electrons that passed must be 0.160 moles of electrons. All right. Now, here we go. There's the charge. Okay. Now, let's have a look at this. So 0.160 moles of electrons passed, and that has a charge of 16,200 coulombs. Okay. Now, therefore, 1 mole of electrons must have a charge of 16,200 divided by 0.16. I'm getting squashed up now. Let me push this up a bit. Okay, so that's the coulombs, number of coulombs for 1 mole of electrons. Now, let me rewrite this. And therefore, 1 mole of electrons, where are we, is this one. Therefore, the number of electrons, this is coulombs, don't forget, and we divide this by the charge on 1 electron, which is 1.6 times 10 to the minus 19, and the coulombs up here will cancel with the coulombs down here, and we'll get the Avogadro's number. So this will give us the number of electrons in 1 mole. Okay, so let me do that. So 16,200 divided by 0.16 is equal to that. Divide that by 1.6. Oh, this is annoying. I'm using the wrong calculator because that calculator doesn't have a standard form, so I'm going to have to use the laptop calculator. Sorry about this. This is why you should do these at a double time, eh? Because I faff around and trying to look for stuff. Okay, divided by 0.16 is equal to that. Divided by 1.6 exponential minus 19. Let's hope I get this right. Gosh, obviously it doesn't have standard form, does it? But it gives me, according to this, 6.32 times 10 to the 23. Okay, now there you go, and that's therefore Avogadro's number. All right, this is so going backwards. What did I do? Found out the coulombs that passed. Found out the number of moles of copper. Found out the number of moles of electrons. So therefore, I could equate the number of moles of electrons to this charge, and therefore 1 mole of electrons would have this charge, and therefore dividing that number by the electronic charge, sorry, the coulombic charge of 1 electron will give me how many electrons that passed, and therefore that's 1 mole of electrons. All right, thank you very much. If I've got this wrong, please tell me anything and I'll rechange it and I'll do it nicer. All right, bye bye.